Okay, here we go. So, this is the next video in our little series. This one is going to focus very much at the higher tier level. Okay, so if you're looking for something a little bit crossovery, there will still be some things in here which you can take from this, but we're going to be stretching into a lot more of a kind of higher tier material. So yeah, we're going to look at circles, graphs of circles, which means we're going to be looking at the equation of a circle as well. And we're going to do a little tangent towards the end as well. Pun intended. So here we go. Now, if I'm thinking about circles, we could also be thinking about areas of circles and things like that, which I'm not really going to focus on for this video. If you want me to look at area of circles and circumference of circles and things like that, let me know. Shoot me an email. Okay. Here we go. So the first thing I want to know is I need to know the equation. Okay, and to know the equation, we need to take a little bit of a detour. Okay, our first of our couple of little tangents. Okay. Now, if you have looked at the equation of a circle before, hopefully you would have looked at, how the equation of a circle comes about. Okay. So let's take this point up here. Okay, this point has the coordinate 3, 4. Okay. Now, that coordinate 3, 4, if we look at it in terms of its a length across and its length up, we get this nice little right angle triangle. And what we can work out from that right angle triangle is the radius of this circle. Okay, we can see that the radius is going to be the hypotenuse of that right angle triangle, and the right angle triangle has got sides 3 and 4. Now, if we know our Pythagoras' theorem, which hopefully we do, we would be able to say that the 3 squared plus the 4 squared would be equal to the radius squared, the hypotenuse of our right angle triangle. Okay, and we would be able to carry through this and say 9 plus 16 is equal to the radius squared, or 25 is equal to the radius squared, which means that the radius will be equal to 5 because we can square root both sides. And indeed, if we were to look, if I get my laser pointer, if we were to look at the radius straight down, it's 5 units. We will look at the radius straight across, it's 5 units. Okay, so my radius being 5, we can see that the radius of the circle is 5. But even just from doing that, we've already given the equation of a circle. If we look to generalise that top line a little bit, the 3 was just how many units across, or, our x value. So we've got x squared. Our 4 was just our units up, or our y value. Okay, because remember that vertical axis is our y-axis. So we've got x squared. That's the world's worst. What is going on? Get back here. Okay, there we go. So we have x squared, and then our y value squared, and that is equal to the radius squared. Now, this wonderful thing here is the equation of our circle. X squared plus y squared equals radius squared. Hey, and that's our beast. That's our thing. So that is an equation that we are not given. We will need to know that equation. X squared plus y squared equals your radius squared. But if you know your Pythagoras' theorem, you also know the equation of a circle. So it's like 2 birds with 1 stone. Okay? So if we know the radius, we know the equation, and we can check to see if things are on the circle or inside the circle or further away from the circle, because if they're inside the circle, the radius would be less than the actual radius of the circle, and if things are outside of the circle, then they would be bigger than the radius when we plug them into the formula. Okay, so one thing that we might be able to ask, or might be asked, here's the circle, what's the equation? Or, here's an equation, draw the circle. And that's what we're going to look at first, those kind of quick questions, the quick maybe 1 or 2 markers maximum. Okay. So, I'll actually give you a moment to look at these questions. You can pause the video here. I'll give you a little bit of a chance to have a look and to have a draw and see what you think the answers will be. Okay. If you've not paused the video, pause the video. Make sure that you take part. Treat it like you were doing this in a normal kind of environment for your lessons and stuff like that. Okay. So that one on the left, it says the circle has an equation x squared plus y squared equals 15. Draw this circle. Now, if I remember my equation of a circle, it says that x squared plus y squared is equal to my radius squared. So 15 is not my radius. 15 square rooted is equal to my radius. Okay, now my trusty calculator is to my right, and the root of 15 is 3.87. So not quite 4. Now, my advice when drawing circles, if you've got your compass, measure out 3.87 units. So for me, that would be like there. Measure out your compass, and then draw your circle. Okay. If you don't have a compass, first of all, get a compass. But I would try and mark out that same distance on all of my axes. Okay, 3.87 units away. 1, 2, 3, 3.87 is going to be down there. And you can see then you've got your circle that hopefully will fit through each of those points. Okay, maybe I was a little bit off with this one on the right. Okay, so there we go. There's one thing. Quick 1 marker maybe. Question on the right says, what is the equation of this circle? Now again, the equation of a circle is x squared plus y squared is equal to your radius squared. Now, we will need to know from this picture what the radius is. Okay, in each of these cases, it looks like it's going halfway through a box. So it looks like the radius of this circle is 2.5. Okay, so I just need to know what 2.5 squared is, which is 6.25, and I can replace that in the equation right at the top. So my answer for this equation on the right-hand side is going to be x squared plus y squared equals 6.25. Okay, not enough for us to put 2.5 squared. I would say that that's a little bit lazy. Prefer to have the 6.25. Okay, so that's 2 things we could be asked to do. We could be asked, here's a circle, what's the equation? Or we could be asked, here's an equation, what's the circle? Okay, now if you're looking for your crossover, you're there just going, I just want a grade 5. I really just want a grade 5. That might be all you look to take away from this. Okay, but if you're looking to push yourself that little bit further, but maybe extend yourself that little bit more, you're going to want to be very attentive for what happens next. Okay, the next logical step for me in thinking about circles is to move away from the drawing and instead to think about the algebra. Now, the algebra with this, one second. The algebra with this normally thinks about gradients and kind of the lines that you could draw within your circle, or checking to see if a point is on a circle. Okay. Now, I'm going to give you, like I say, I'm going to give you a chance to pause, take a look at these questions, and see what you think. If you feel like you know what to do, give them a go, and then we're going to go through them afterwards. Okay, so I'll give you a chance to pause the video here. Sufficiently awkward pause, I think. So, remember that your coordinates always come as an XY pair, okay? Your first number is always your X value, and your second number is always your Y value. You will have known that from, like, I don't know, year 6 or year 5 or something like that. You know, always comes in an XY pair. Now, we know what this equation is. We know that the equation of this circle at the top is x squared plus y squared equals 25. So the only thing we can do here is to plug in the numbers and see if it works. Okay, so we've got 3 squared is my x value. Now, -4 squared, I would stick in brackets, especially if you're on a calculator paper. Okay, and we are checking to see if this equals 25. Now, I am going to just explain why you should look to put those things in brackets. Now, calculators are pretty smart. I'll give them that. They're pretty smart, but they're not as smart as humans. Okay? Because, of course, humans program the calculator. Now, if you type that thing in here, if you type that in your calculator as it is, nothing will go wrong. If, however, you type it into your calculator and you're a little bit lazy, things will go badly for you. Okay, so you can now see my calculator up on screen. Okay, if I type in bracket -4 squared equals, I get 16, because we know that -4 times -4 is 16. Always has been, always will be. But watch what happens if I don't put those brackets in. Calculator says -16. Now the reason why is because we use the subtraction sign. Okay, that calculator is reading this as do 4 squared, then take it away from nothing. So you're going to have to take away 16, which is why we get -16. If you use the actual negative button on your calculator and type it in though, it still goes wrong. Because this time it's going 4 squared and make it negative. You have to put those brackets round things if you're dealing with negatives and squaring things in your calculator. Put brackets around them. Please put the brackets around them. Anyway, getting sidetracked. Now here we can see that we get 25 equals 25. Now that's a good thing. It shows us that this equation works and that this point must be on the edge of the circle. In fact, it's down here. Okay. We use the equation to verify that. If I had 24 equals 25, that means that I'm somewhere inside the circle because I'm less than the radius. If I had 26 is 25, then I'd be outside of my circle because I am bigger than the radius of the circle. Okay? So this one is good. It is on the circumference. I'm just going to put circ to be a little bit lazy. Not bad lazy, though. Just good lazy. And the question underneath, if you have watched this, the video that I posted before this one on linear graphs, this would be a little bit of a refresher for you. Find the gradient of the line connection. I think connecting I meant to type there. Find the gradient of the line connecting the center of the circle with the point 3, -4. I'm going to do this in purple. So that's this line here. Okay. Now, if you remember your gradient is change in y divided by change in x. Or you might have heard this if you're from a different group, rise over run. I'm going to get rid of my calculator now. We've had enough of calculator for a little bit. So my change in my y, I have come down by 4. So that's -4. And I've come 3 units across. So my gradient is -4/3. Okay, there we go. Happy days. So not only can we draw a circle given an equation, not only can we get the equation from a circle, we can check to see if something is on the circle, like we did above, or we can check to see what the gradient of a radius in the circle will be from below. Now we're going to step things up again, okay, to what I would say are perhaps some of the more difficult things that you could look to do with circles. Okay, stuff maybe like this. It says going off on a tangent, and as I said before, pun is intended. Okay. Now, tangents. We have a tangent that touches this circle at the point 4, -3, so slightly different from before. Estimate the gradient of the tangent. Okay. So, what we would do, if you remember, when we're looking at estimating gradients of curves, we would draw a tangent on the curve at the point that we are looking at, and we would work out the gradient of the tangent. So the line in purple for this screen here. Okay. Now, as before, we said that our gradient is our change in y divided by our change in x. If you go on to do a S level or A level maths, you'll see this notation a little bit more. This Greek letter for delta just means the change of. Okay, just means it's just a little shorthand. Now this line is really awkward because it's really not clear to tell like any good spaces to start or anything like that. So I'm going to start down here, and I'm going to go across as far as I can, and I'm going to end up there. If in doubt, make your gradient triangle as big as you can. Okay, it will try and make it as accurate as you can. So what have I done? I've gone across 1, 2, 3, 4, 5, 6, 7. I've gone across 7 squares, and I've gone up 1, 2, 3, 4, 5, 6, 7, 7.5. That's like 0.8. So 7.5 plus 0.8. That's not pleasant. Why did I do this? This is 8.3. Roughly 8.3 squares up. It says estimate. I'm allowed a little wiggle room, just a little bit. My change in y is 8.3. My change in x is 7. And 8.3 divided by 7 is apparently 1.19 to 2 decimal places. Which is not great. It's not great. But, you know, it's an estimate. It works okay. However, we can do better than that. Okay, as the question underneath shows. And again, if you've watched my previous video on harder linear graphs, you'll find a few things familiar here as well. Now, tangents are always perpendicular to radii. That is a circle theorem. Don't forget your circle theorems, kids. Now, I'm going to try and link up my radius to my point. It's kind of like that. It's not quite, but it's close. Okay. Now, hopefully we remember that perpendicular lines have gradients that link. Now, I just want you to think to yourself, perpendicular lines, gradients, what's the link there? What's that link? And if you're thinking that those links are negative reciprocals, then we're on to a winner. Okay? So we're going to look for negative reciprocals. Now this radius here, I need to know the gradient of my radius. And again, change in y divided by change in x. My change in y is I've gone down by 3, so negative 3. My change in x has gone across by 4, which is just 4. Is negative 3/4. So now if we want the gradient of my tangent, I'm going to have to find out what the negative reciprocal of 3/4 is. Okay, the negative reciprocal of 3/4, let's put m tan for m tangent, is going to be, make it negative, so in this case it's going to change from negative to positive, and then flip it upside down. So 4/3, which is a decimal, is 1.3 recurring. So our estimate of 1.19 isn't far away, but it is inaccurate. Okay, and you've always got to remember that estimating gradients using tangents will be inaccurate, but sometimes it's the best that we can do. Okay, sometimes it is just the best that we can do. Okay, and there we have it. We've got our we've got the gradient of the line perpendicular to our radius. Okay. Excuse me for 1 second. I just need to cough. Okay. Now, other things that we could see here, other things that we can do. These, we can incorporate many different things. These are just some of the things that spring to mind when I think of circles and equations of circles. But there are other things that we can do as well. Where we are splitting things off between a tangent and our radius, we end up with right-angle triangles, okay? Which means that we could use right-angle triangle trigonometry. Okay, I could be asked to work out the length of my radius, which we know how to do from earlier in this video, and we might be asked to work out the area of this triangle, in which case we could use base times height divided by 2, or we could use half AB sine C for the advanced trigonometry. If you're looking for a video on advanced trigonometry, did one before, check it out. Okay, we might be asked to work out the angle between the radius and the x-axis, and again, that would just be trigonometry. Okay, looking at how far you've gone down, how far you've gone across, you've got an opposite and an adjacent for us to be able to use tan. Okay, so there is a lot of stuff that could be asked within this, and I could make a video that goes on for an hour about using circles and equations of circles and things like this, but everything that we could reasonably look to think about with equations of circles, we've had a go through here. Working out an equation, drawing a circle, working out if a point is on the circle, working out gradients of a radius or gradients of a tangent are things that we could want to know how to do. Now, if you are thinking about area of a circle, remember pi r squared, pi times radius squared. If you're thinking about circumference of a circle, pi times diameter. Okay? If you're asked to give your answer in terms of pi, remember, leave pi out of all your calculations, put the pi back in at the very end. Okay? There is a resource that if you're checking things out here, I've attached for you to be able to have a look at. Uses all of the different things that we've done here, and I think there's one question right at the very end which is really, really, really good at stretching like just how far you can go with this. Okay, I think it uses a little bit of area as well. Okay. But yeah, check out those resources. I think I've attached the answers as well, just in case you're looking for clarification on things. And as well, use this as part of your revision. That's why I'm making it, making life easy for you, because I'm treating you guys well. Okay. Try out the questions, and yeah, I'll see you in the next one. Bye bye.